YouTube channel. Today we will discuss evaluation of limits of functions. Okay? I'm Nwachukwu Daniel. Please, if you have not subscribed to my YouTube channel, please don't forget to do so. Okay? I will appreciate. We want to discuss evaluation of limits. There are many methods needed or you can use to evaluate limits. 1. By direct substitution. 2. By factorization of the numerator or denominator or both. 3. By dividing with the highest power of the independent variable. E.g. x. 4. By rationalization of either the numerator or denominator or both. And 5. By L'Hopital's rule. So these are the possible methods one can use. Once you use direct substitution and it did not work out, use any of this rule. The rule number 3 is only used when s tends to infinity. Rule number 3, divide with the highest power of the independent variable, is only used when s is tending to infinity. So what you do first, like question number 1, take they say that a is tending to 0. Take a equal to 0 and put here. 9 plus 0. 9 plus 0 will give you 9 minus 3 all over 0. Square root of 9, 3. 3 minus 3, 0 over 0. You see, it gives us indeterminate or undefined. That means we cannot use direct substitution. You think of which rule apart from direct substitution and apart from rule number 3. Between 2, 4 and 5, which of the rule will work out? You try rationalization of either the numerator or denominator or both. Yes. Why do we say let's try that one? We pick that one because the numerator, which is square root of 9 plus a minus 3, has a conjugate. And you know that conjugate simply means opposite. So opposite of this minus is square root of 9 plus a plus 3. So this is conjugate of this. Please, conjugate of 9 plus a minus 3 is not square root of 9 minus a, maybe minus 3 or maybe plus 3. No. As far as this square root has covered everything, do not change the sign there. Only change the sign that is connecting this square root and another number. Only change that one. If it is minus, change it to plus. If it is plus, change it to minus. That is very important to note. So, conjugate of this will give you this. So, we use that conjugate to multiply up and down. We say square root of 9 plus a minus 3 all over a times square root of 9 plus a plus 3 all over square root of 9 plus a plus 3. So use it to multiply up and down. Now multiplying, we will be having this times this. Square root of 9 plus a times square root of 9 plus a will give us 9 plus a. Square root of 9 plus a plus times square root of 9 plus a will give us 9 plus a. How do we know? Square root of a times square root of a will give you a. So you say this times this will give you 9 plus a because they are the same. This times this will give you plus 3 root 9 plus a. This times this will give you minus 3 root 9 plus a. Then this times this will give you minus 9. This will cancel this. This will cancel this. All over a bracket square root of 9 plus a plus 3. Now, what we will be having is a all over a bracket square root of 9 plus a plus 3. This will cancel this, leaving you with this. Now, as you have gotten 1 over this now, carry your 0, a equal to 0, and put. That will be giving us, when you put it here I mean 1 over. When you put 0 as your a here, you'll be having square root of 9 plus 0, then plus 3. 9 plus 0 is 9. Square root of 9 is 3. 3 plus 3 is 6. So that will be 1 over 6. That tells you that limit of this at a tends to 0 is 1 over 6. Answer. Then we go to the question number 2. To solve question number 2, we say take limit of this all over this. Now, what you do is that, remember that square root of x squared minus 2x cubed plus 1 all over 2 minus 6x minus 7x cubed. Now, because they say x tends to infinity, use rule number 3. Rule number 3 says divide with the highest power of the independent variable. So, we will apply rule number 3 because s is tending to infinity. Only when s tends to infinity that we use rule number 3. Don't use any other rule where s tends to infinity. When you use any other rule, you are very wrong. Now, this thing you have is the same thing as square root of x raised to power 6 minus 2x raised to power 3 plus 1 all over square root of 2 minus 6x minus 7x cubed all raised to power of 2. Because this cancels power of 2, it will return back to this. Now, that tells us that everything will now be x raised to power 6 minus 2x raised to power 3 plus 1 all over 2 minus 6x minus 7x raised to power 3 all squared. Now let's expand it. 2 minus 6x minus 7x raised to power of 3. 2 minus 6x minus 7x raised to power of 3. Now to expand, 2 times 2 will give us 4. 2 times minus 6x will give us minus 12x. 2 times this will give us minus 14x raised to power of 3. Come to this. Minus 6x times 2 minus 12x. Minus 6x times 6x plus 36x squared. Minus 6x times this plus 42x raised to power of 4. Now come to this times this minus 14x raised to power of 3. This times this minus 14x raised to power of 3. This times this plus 40 plus 42x raised to power of 4. Right? Then this times this plus 49x raised to power of 6. Okay? Now what you do, collect like terms. You write 49x raised to power of 6. Then seconded by this and this plus 84x raised to the power of 4. Next will be power of 3. Power of 3 minus 28x raised to the power of 3. Then plus 36x raised to the power of 2. Then 12 minus this and this will be giving us minus 24x. Then plus 4. That is expansion of this. Now see what we do now. From the expansion of this, we have that the highest power is 6 here, and the highest power here is also 6. You say x raised to the power of 6 all over x raised to the power of 6. Use the highest power to divide everything. Minus 2x raised to the power of 3 all over x raised to the power of 6 plus 1 all over x raised to the power of 6 all over 49 x raised to the power of 6 all over x raised to the power of 6. Then plus 84 x raised to the power of 4 all over x raised to the power of 6 minus 28 x raised to the power of 3 all over x raised to the power of 6 plus 36 x raised to the power of 2 all over x raised to the power of 6 minus 24 x all over x raised to the power of 6 plus 4 all over x raised to the power of 6. So that is what we will be having. So what we do now is we now sort it out. To sort it out, what we do is I say x raised to the power 6 over x raised to the power 6. That will be giving us 1. Then when this divide this, the denominator will still be having x. That is x raised to the power of 3. See, this denominator is still having x, and they say that x is tending to infinity. It means that as the denominator is still having x, it will automatically become 0. Then as the denominator is also still having x, it will automatically become 0. All over, this over this will be giving you 49. Then this divided by this, the denominator will still be having x, so it will automatically be 0 because it's tending to infinity. This one divided by this, the denominator will still be having x after the division, so it will automatically be 0. Okay? Minus 0. This one after the division, it will still be having x, like x raised to the power of 4. The denominator will still be having x raised to the power of 4. So it will automatically be 0. Then this one, after division, the denominator will still be having x, it will automatically be 0. This one is still having x at the denominator, so it will automatically be 0. So that will be giving us square root of 1 minus 0 plus 0, 1 all over 49 plus 0 minus 0 plus 0 minus 0 plus 0 will be giving you 49. That is 1 over 7. So you say this one is 1 over 7. That is the answer. You follow it sequentially. Now, the second to the last question says, it says, leave as sine 2s all over 1 minus cos 3s as s tends to 0. Try substitution method first. To try it, say sine 2 times 0 because s is 0 all over 1 minus cos 3 times 0. That is 0. That will be giving you sine 0 is 1. Sine 0 is 0 all over 1 minus cos 0 is 1. 1 minus 1 0. Indeterminate. So you use any of the method to solve it. Let's think of method we can use. We can use L'Hopital's rule, which applies principles of differentiation. L'Hopital's rule simply means write sine 2x all over 1 minus cos 3x. Differentiate the denominator on its, differentiate the numerator on its own. That will be giving you 2 cos 2x. All over, differentiate 1, 0. Differentiate cos 3x. That will be giving you minus 3 sin 3x. So that will be giving you finally. Now when you carry 0 and put 2 times 0 is 0. 2 cos 0 will be giving you 2 all over. Minus times minus plus. Carry 0, put here. 3 times 0, 0. 3 sin 0 will be giving you 0. Still undefined. The implication is differentiate it again. Differentiate this. It will be giving you minus 4 sin 2x. All over this minus times minus will be giving you plus here. So you'll be having it as 3 sin 3x. So differentiate this. This will be giving you 9 cos 3x. Okay? Now carry 0 and put. Minus 4, 2 times 0, 0. Minus 4 sin 0 will be giving you 0. Remember, minus 4 sin 0 is equal to 0. Sin 0 is 0 times 4, 0. All over 3 times 0, 0. Cos 0 is 1. 1 times 9, 9. 0 over 9 is defined. It will give you 0. Remember, 0 over a number and a number over 0 are not the same. This one undefined, whereas this one is defined. So 0 over 9 will be giving you 0. So he said that this one will be giving you 0. Then we try the last question. The last question says, leave as this minus this all over this as s tends to 0. What you do is that you can also apply L'Hopital's rule. Differentiate everything in the numerator differently. Differentiate the denominator differently until the denominator will not have alphabet x again. Now differentiate sin 4x, it will give you 4 cos 4x minus differentiate sin 3x, it will give you 3 cos 3x. Differentiate x, it will give you 1. Where s is 0, put 0 here. 4 times 0 is 0, cos 0 is 1. 4 times 1, it will be giving you 4. When you put 0 here. 4 times 0, 0, cos 0 is 1. 4 times 1, 4. 3 times 0, 0, cos 0 is 1. 1 times is minus 3, all over 1. That will be giving you 1. That is the answer to these limits we have. Okay? Thanks for watching the video. Please don't forget to subscribe to my YouTube channel and turn your notification button on, and see me next time.